Hello, Algebra 2 students. It's day 2 of Unit 11, and we're going to be looking at transformations of exponential functions. So from yesterday's notes, what you should know is that when the b value is greater than 1, this means we're looking at an increasing function, or under here you'll see a growth function. Oops, it's right down there. There we go. And the y-intercept is here at 1. And then it should be increasing as I head to the right, and then approaching 0 as we go to the left. Other little details, it has a horizontal asymptote right there at 0. Whereas the other equation, when b falls between 0 and 1, this would be a decreasing function, or also known as a decay function. You'll still find the same y-intercept right here at 1, and then it would be increasing as we go to the left, and then decreasing as we head to the right, and bottoming out at 0 there. So we still have the same horizontal asymptote, just like that. All right? So when it says, what are the critical points? I'm going to slide up a little bit here. The critical points is that the y-intercept is always at 0, 1. There's a horizontal asymptote. Right at y equals 0, which is essentially like a little invisible line that the graph can't cross. And then as for the last part, we're going to pick something called an accuracy point. And you can actually say point or points. So it gives us an extra point to plot to make the graph accurate. Or more exact versus just kind of floating out in midair. Some other little things you'll note is that for the parent function, which is what these ones are, they're the most basic form, y equaling b to the x here. There are no x-intercepts. Once we move it around or transform it, you'll see x-intercepts possibly appear, but it always starts with the y-intercept at 1 and no x-intercept to begin. Now at the bottom of the page, you're going to see, oh my goodness, all these rules. We did transformations earlier in the year. The idea that when there is a number multiplied in front, that is a vertical dilation, whether it's stretching it out or kind of squishing it, depends on the a value. If you shift it left or right, you're going to see something added to the x in the exponent. If it shifts up or down, you'll see something added to the n, so the k here. And then there's also the detail of if a is negative, it also is a reflection over the x-axis. If the x itself is negative, it's a reflection over the y-axis. You're more likely to see the negative a than you are the negative x, but it's good to note. So let's put this to good use. When we flip to the next page here, what I want you to do is I want you to be able to look at the equation and kind of strip away any transformations that are happening back to the parent function. So let me remind you, the parent function is in the form of y equaling b to the x. So and the b here would just be the 2. That stays. So y equals 2 to the x power would be the parent function. Based on that, we know that because 2 is greater than 1, that this would be a little increasing function. So I'm just going to sketch what that looks like right now. We are going to mess with it, but not yet. So for the parent function, let's talk about the basics. The y-intercept is always at 0, 1. The horizontal asymptote is always the line y equals 0. And then as for an accuracy point, we said it's an extra point you're going to plug in and come up with. We can plug in like x equals 1 or x equals 2. I tend to just plug in a 1. And so when I mean that is I would plug into this parent function, because remember, that's the parent there. So y equals 2 to the first comes out as 2. So that means the point 1, 2 would be on that graph, because here's your x, that's the y. All right, now we're going to transform it. So take a look at what's happening here. We have a +4 up in the exponent. We have a +3 on the end. If you need to, I'll put my sheet back up here. Up top with the exponent. If it's positive, we're going to the left. If it's negative, we're going to the right. Remember, it's always a little opposite with the x's. And then on the end of it, if it's positive, it goes up. If it's negative, it goes down. So with that being said, because it's a +4, this thing is going to translate, or you could say simply shift, and it's going to go left 4 units. And then the 3 on the end means it's going to translate or shift up 3. So what we want to do is we want to take these 3 details from the parent function and walk it through those transformations. You have a graph here to help you, so use that for a visual. So if I take the point 0, 1, and I'm not going to plot that point, I'm just going to kind of find it on the graph. So here's 0, 1, and I'm going to walk it to the left 4 units, so 1, 2, 3, 4, and then move up 1, 2, 3. Right here is where I can actually plot that point. And the coordinates of that point are -4, 4. So that's where the y-intercept will move to. So it's no longer a y-intercept, and that's okay. Right, the horizontal asymptote, the line y = 0. So if I have a horizontal line here, if I shift it to the left 4, it's still the same line. But if I shift it up 3, now it's a different line. That is now the line right here, which would be y = 3. So there's your new horizontal asymptote. As for my accuracy point, find the point 1, 2 on your graph. So if I go over 1 and up 2, from here, I'm going to walk it to the left 4. So 1, 2, 3, 4, and up 1, 2, 3. All right, that arbitrary point just moves. It's now -1, 2, 3, and up 1, 2, 3, 4, 5. So I could have taken any point on the original graph and shifted it. I just picked something simple to work with. All right, if I now connect the dots and I think about the shape, I didn't flip it over, I didn't stretch it, I just shifted it left and up. It's going to maintain that same shape, looking kind of like this. And now I can answer the questions about it. So the domain, it's going to cover everything from -infinity to +infinity. The range, when I think bottom to top, well, it bottoms out here at 3, but it never hits 3. So it's a parenthesis on up to infinity. For the end behavior, as x goes to infinity, so as I look to the right on the graph, it shoots on up to +infinity. As x goes to -infinity, so as I go to the left, the graph approaches 3 itself. And there we go. Now, if I wanted to double check it, could I grab my calculator and type this in? Absolutely. So if I go 2 and then I raise it to the x, oops, let me get rid of this. If I do 2 and then raise it to the x + 4, and then out here +3, and if I zoom 6, there's going to be the graph that we just sketched. So when you have a nice equation, you can absolutely use the calculator for reinforcement or to help you kind of fill in any blanks. The reason we approach it this way is if I were to give you a generic graph and then say shift it this certain direction or action or reflect it this way, I'd want to make sure that you could handle it without the support of your graphing calculator. All right, let's do one more where we walk through those same steps. So here, f of x = 3/4 to the x - 2 and then -3. The parent function, again, in this case, you could say f of x equals, but we're stripping away any transformations and it's just going to be the base raised to x. So this is just simply y = 3/4 to the x power. 3/4 is between 0 and 1, which means this is a decreasing function. So before I start, I want a visual to know, okay, this is going to decrease. On the parent function, y-intercept, raise that to the 0 power. It always comes out as 1. Horizontal asymptote, y = 0. Accuracy point. Just to show you, you can pick any value of x you want. So I could plug in a 1 here, maybe you plug in a 2. I tend to just pick 1 because it's easy. So 3/4 to the first power is just 3/4. So this would be the point 1, 3/4, just like that. Now let's talk about the transformations. Starting closest to the exponent, or to the base, I should say, and working my way out, I've got that -2 first. So since it's a -2, this means that we are going to translate or shift to the right 2 units. The -3 on the end means that we translate or shift, you can say it either way, down 3 units. So let's take each of those points again and walk through those transformations. So starting at 0, 1, so right here on my graph, I'm going to go to the right 2 and down 1, 2, 3. That's now the point 2, -2. All right, the horizontal asymptote, y equals 0. If I go to the right 2, it doesn't go anywhere. But if I go down 3, that will move that line down here to the line y equals -3. All right, my accuracy point. I'm at the point 1 and then 3/4. Okay, if I walk it to the right 2 and then down 1, 2, 3, that's going to be the point 3. And then keep in mind, I took 3/4 and moved it down 3. So I said 3/4 and I subtracted 3 from it. So -2 1/4. All right. And now think of the graph. We didn't flip it over. We just shifted it around. So it's going to maintain that same shape and look a little something like this. As for the domain, always -infinity to +infinity. The range, it bottoms out at -3 and goes up to infinity. As x heads to infinity over here, the y value is approaching -3. As x goes to -infinity, going this way, y is shooting on up towards +infinity. All right. We will save number 3 to do is maybe some practice in class. And then as for the last part, it says, what conclusions can you draw about the end behavior?